Howdy, my name is Ethan Van Swearingen, and this is the gear ratio time dilation simulation. Let me explain why. So with this, we can show you, this would be like how a clock behaves. This would be like seconds, this would be like your minutes, this would be like your hours, days, and so forth, right? You can see they get slower as you move backwards. Now, this is the same thing, except I've added a manual crank. This would be like a clock with a manual crank. So, with each gear, subsequent gear, they get harder and harder, or slower and slower as you go farther. Like, in order to crank this top gear one full rotation, you have to crank this 60 times. In order to rotate this second gear, it'd be 3,600. Third, 216,000. Fourth, 12.96 million. And the last one would be 777,600,000. If you were to crank this once per year, that would be like waiting for the sun to orbit around the Milky Way 2.5 times. Now this is the same exact thing, except I've added one more gear. And now in order to rotate this last gear, one full rotation would be like 46 billion ticks. So you'd have to crank it 46 billion times, which is actually the observable universe's radius in light years. So every time you're taking this, you're traveling 1 light year across the observable universe's radius. And as you can see, you're traveling faster than the speed of light and you're going nowhere across the universe. Now, I mentioned a time dilation simulation. So in general relativity, Albert Einstein says that as you approach a heavier body or mass, stronger gravity, time will actually be perceived to slow down for the person moving into the stronger field. Now vice versa, they'd be speeding up. Now let me explain. So we can take this gearbox right here, and it has a manual crank. It's our way of measuring how much time dilation occurs. So if I take this box and you're standing out there in space watching me approach a stronger body of mass, as I get closer and closer, you're going to see me slowing down. Now on the flip side, if I give you this box and I move towards a stronger body of mass, I will be looking at you holding the box and also you speeding up as I get closer and closer to the stronger gravity field. So stronger gravity means that for you, you'll see time passing faster for those on the outside, and vice versa for someone looking at someone approaching a stronger field. They will see you slowing down if you're moving towards stronger gravity. Now that's fun because you could literally lay on the ground and time will speed up for you. Thank you. That's my demonstration.